Welcome to another GCBASIC demonstration. This is part 19 for the PIC18FxxQ20 series. This is around assembly, alternative assemblers, and MPLAB-X. Let's have a look. Please like and subscribe and let the video run all the way through. If you don't know, those are the metrics that YouTube use to push these videos to our consumers or users. So this is part 19, one more to go after this, and I'll change chip. So what we're going to look at is really generating some very simple code and then pushing that code into MPLAB so you can debug it if you need it. There are better ways of debugging personally. I think you'll find that serial is just as good, but lots of people want to be able to push code into MPLAB. And it's not hard. It's extremely simple. I'll give you a full set of instructions. So GCBASIC is an open source compiler for PICs, AVR, LGT. So anything you can do here on PICs, you can do on AVR and LGTs. And having the Q20 latest chip works is fantastic, really. And so what we're going to do is we're going to take our high level language, and I'll just draw my pen on here. We're going to take our high-level language and we're going to push it through the preprocessor. I don't think we'll be using any libraries. Actually, we'll be using a library, so it'll be pulled in. It'll go through the code translator. It'll go through to the assembler. And at that point, then, we're going to push it outside to another assembler. And that is going to be like this. So we're going to come along. We're going to go out into PIC-AS, from PIC-AS, get it to do the assembly and link it out and then generate our absolute machine code. And we'll get a lot more files as a result because we do get a lot more files with PIC-AS. Time-wise, not a lot of difference, but some people want to be able to do it. And this is the way to do it, to put it into the debugger. So what we're going to do, we're going to review a very simple LED program. Then we're going to create a project, specify the chip, select PIC-AS as our tool chain, put a project name in, press finish. And then we're going to add in our GCBASIC source program, what's called a .s file, into that project. We're going to make 2 more changes, and then you can actually program it as well, which is step 7. And step 8. Step 8 and 9, we'll actually compile it up and use the simulator to see what's actually happening. So, step 1, let's review our simple program. Well, we'll start with what it's actually doing. It's flashing an LED. Relatively simple. So here we go. I'm looking at the GC code IDE, press Control B, and I get a list of all the files that are in here. And I'm looking in here for, there's lots of files and lots of extensions. Control F. If you're in here, just press Control F, .gcb on that little diamond triangle at the top, and it will then filter on all the source files. So I'm actually looking for 310 using MPLAB-X. Control B to shut that list down. And this is our program, extremely simple. We'll have a look at it. Standard, specify the chip, option explicit. This is all the ports. We've seen this many times. It basically sets up a set of constants to address the LEDs and switches, etc., and then sets them to inputs or outputs or inputs. Very simple. And then our program, our real big program, it's doing this. It says a do loop, which is this do loop here, and it says set LED D7, whatever that equivalent is as a constant to 1, wait 1 second, set it to 0, wait 1 second, repeat. So that's what makes it flash. And if you want to see how that works, we can do it in a number of ways. So if I just see what the setup's like, function key F4, edit preferences, we can go into the preferences editor. I'll bring it into view. And I'm just going to look at my compiler in here. And it's selected to PIC-AS, and that's the one we need. Now let's just put it to GCASM for a moment, and we'll see how long it takes to compile it. full screen so you can see it. Make sure I'm not kidding you. Press hex, make a hex file, and it takes, let's have a look, 2.26 seconds. So look, this compiled here in 2 seconds, and then GCSM took 0.26. That's 2.3 seconds. Just make sure you believe me. 2.3, adding up that time here and that time there. Let's just turn it back to PIC-AS, function key F4, get the list up, edit preferences, zoom in on that for you, bring it into view, compiler, PIC-AS. Now, I'm running the latest version of PIC-AS, just so you know that, 2.5. That was released today, and I've just changed in my location here. If you haven't got 2.5, you might have 2.46, but it just needs to be the correct version. Press OK. So what I've done, I've changed it from GCSM, the internal, to PIC-AS. I'm going to make a hexadecimal file. I've done that at the top, hence it's cleared the screen. 2.03, 1.7. So it takes slightly longer. So that's now it's about the same time. It's very similar time. It doesn't take any longer, but we produced another file. And that another file is the source file called a .s file, and that file is suitable for MPLAB-X. In the old days, we used to generate just the ASM file, .asm file, and that would be very good for the old MP-ASM. Lots of acronyms there. But these new chips aren't supported by MP-ASM, only PIC-AS. So we've now got a source file. And if I want to see that source file, press function key F4 to get the menu up. You just type in open. It says open S. And that S file is the source file that we're going to be using. There it is, look. Fantastic, look. And it is a source file for MPLAB-X. Right hand mouse button. I'll just take a copy of the path. There we go, got it. All right, let's open up MPLAB. MPLAB. Open it up. Let's look at our PowerPoint, because what we've actually done is the first few steps in here. Let's look at our PowerPoint. We've viewed the simple LED tick. I've just opened up MPLAB. We'll create a standalone project, specify the chip, etc. It still hasn't loaded. We'll select the simulator, PIC-AS as our compiler name, give it a name, and then we'll select finish. We're going to do all those in the next few seconds once MPLAB has decided to load, okay? I think it's there now. Is it? No, there it is. I'm using 6.20. Okay. It's settled down now. Great. Zoom in. File. New project. I have no projects in here. Application project. That's the one you want to select. Let me just move the screen across. Might be different in early versions, but I'm using 6.2. Application project. The root device. Type in Q20 and select your chip. 16Q20. Tool. Simulator. If you've got a PIC-Kit4 attached, you could take that as well. Next. Okay, now these are all the C-based languages. You want PIC-AS, and I've installed 2.5 today. 2.5 is what I'm selecting here. So I'm using the compiler 2.5. Give it a project name, Q20, and I select some folders if you wish, but I'm just pressing finish. So we have done many of the steps shown in our PowerPoint. We've done everything down to the finish here. I just selected finish. Now what I'm going to do is I'm going to add my GCBASIC source, and it's called Add Existing Item to my little project. How do I do that? Well, I'm just going to zoom in on the right-hand side for you. I'll just bring it really into context so you can see it. Source files, right-hand mouse button on there, Add Existing Item, and then I will bring that up for us so we can see it. I took a copy of the location of my .s file into my cut and paste buffer, and I've selected it. Auto and select. In actual fact, if you use select relative, it also seems to work. Select. And it's now added our source file into there. Fantastic. Done it. If you want to know if it's working, at this point, you can actually press production and build a file, and it will build your project. And if I show you the screen, that particular screen, it's just compiled it there. It's just finishing it off. It says here total time 1 second, and this is exactly the same compilation he'd have done under the guise of GCBASIC. But we can do some other stuff. We can change the project so it actually does automatic programming. Let's do that. And that was in the PowerPoint. In here, in the PowerPoint, it says file properties, make some changes to set this up. And it's actually about setting up the simulator, and I'm going to use this to program my chip. So I'm just going to take a copy of this instruction here. I wonder if I can. I'll go back to my PowerPoint. I'll take a copy of this instruction. Where's my source PowerPoint? There. You can't see me doing this. It's on a different screen. I've just taken a copy of the string that was in here. So you can do this. I'll put this up in YouTube. Control C. I am going to do all these instructions. Here we go. Back into MPLAB. Zoom in for you. The quickest way to do this is File, Project Properties. There are other ways of getting into this, but File, Project Properties is always consistent. Microchip haven't decided to change that yet, but they keep changing the UI. Okay. What did it say? Conf simulator. Set the frequency here to 64 because that's what we've got selected over in GCBASIC. And if you're going to run a simulation, you need to have it at the right frequency, otherwise it doesn't work. Building. If you say execute after this line, execute this line after build, and you paste that in, and you've PICKitPlus installed, and you've got it installed in GCSTUDIO folder, it will run the pickit command line, and it will substitute all the correct parameters in there for you, and it will just program it. Okay, so let's have a look at that. I'm just going to zoom out so you can see me press OK. OK. Now, last time it did it, in actual fact, it didn't program it because we hadn't set the programmer up. But this time, I'm just going to shuffle the screen around for you. Is that getting? We'll get there eventually. Production, build main project. It will build it in the 1 second, exactly as it was before. And now what it's doing, it's actually programming it. And it's done it. It's programmed it. So I am now programming direct from, and it's just to reassure you, the LED's flashing exactly the same as it would from GCBASIC. But what you can now do is something very different. You can now go debug, discrete debugger operation, build for debugging the main project. It will compile and produce some extra files it needs. And then we can run our little program inside the debugger. And we can see variables change, etc., etc. So once it's completed, I say, oh, it has done it, but it hasn't settled because there we go. Discrete debugger operation, select launch. It's now launching the MPLAB debugger into in here. Here we go, look. And here is our source program in the debugger, look. You may say it's not the same. I'll prove it is in a minute. So I can press function key F7 and I'm walking my program line by line. Line by line. It's walking through the initialization of the chip. And then here is, if you look in here, here is our code. I'll just get rid of that. I'll clear all the breaks because I must have had some set up from a previous project. Huh. Didn't know you couldn't do that. It won't do a break where there's a comment, so I'm just trying to get rid of that for us. Great. So it's going to break whenever we change the state of this LED, which is on port C7, and this is the assembler for that. Oh, I'm clicking on the wrong screen here, sorry. Remove all breakpoints. There we go. Toggle breakpoint, and then down. That is the setting the LED to out. And here's our major loop here. LEDs set to 1. I'll do a break there. Control F8. I'll do another break when it resets it. Control F8. Now, so bit set, bit clear. And this is the assembler that was generated for you. Press function key F5, and it's now waiting for us. Let's have a look at what's going on inside our variables. Here's the variable for port C. I added it in. I can delete that. I should delete it really. I'm going to add in a new watch, enter a new watch, because we're playing with port C. Port C, SFRs. Oh, where is it? Port A, port B, port C, there we go. And these are the values of port C. So if I actually now increment that by one step by pressing function key F7, the bit here, the 8th bit, port C7, changed. I'll run it. The code will stop after the delay. And it's currently, the high bit is set. Now there's no bit set. This is the toggle. Well, we're seeing it happen real. So it's now cycling through our program. And we can see the values, you can see the RAM, you can see what's happening by looking at the variables. Let me stop that. Go back into GCBASIC. Change the source. I'm going to get rid of these and put a no op just to show you it's actually working. No op. Function key F6 to generate the file. And we will see the source file in here automatically change. It's changed. If we look in our source here, it's got the no op has appeared in here, and the no op has appeared in here. Debug, discrete. You have to recompile for debugging. You can't, you have to do that step. And once it's done that, you're then back into the program. As you know, with these new changes, rather than the delay, we've now got our no op. And you might want to do that. Don't know why, but you might. Now it's just writing out the Q20 files for the debugger. Launch the program. It's launching it, and it's restarted the program for us. And if we look in our program, here's our no ops here. One was here, one was there. Now if I just clear out all those breakpoints, Control F8, this is where it was setting the LEDs before. Run the program by pushing function key F5. We can now step through at high speed. We can look at our variables, and we'll see port C change every other step. Look, it's set in the high bit, therefore it's set to hex 80. And as I step through, magic is happening in the debugger. Fantastic. So you can generate code, make your changes in GCBASIC, and see how it's reflected in the debugger. And when you're good and ready, you can program it because you just press function key F11 after you've made the changes to the properties of the project. Very simple. And that's really quite useful. And I do use that extensively when I'm trying to debug something. It's a good tool to use. And so we went through all those steps on the screen there. So it's really quite useful. But what else I wanted to show you was alternative debug, alternative assemblers. So let's go back to our program. This is back in GC code. I'm going to recall my first sample piece of program, and it's currently with an LGT. You can see that on the screen. Obviously, that's not a PIC, is it? But if I put that to a 16F88, you have 3 ways of generating the hex file. Function key F6. That, oh, let's just make it really simple and put that to A, because I think an A is going to be good enough for what I want to do. So I've compiled it. It will fail to program it because it's not the right chip, but it's assembled it using PIC-AS. That's what we had set. Let's change the toolchain. We're going to put that to GCASM, another way of generating the hex file. Press function F6 or make hex, and it's generated another hex file. But what you can do is change it to MPLAB-X. And some people like MPLAB-X, and happens to be that a 16F88 works with MPLAB-X. Doesn't work. Not all chips work with MPLAB-X. Make the hex file. You'll get a little flash from MPLAB-X as it comes up. There we go, and it's done its stuff. And the goal is that the hex file that is produced, that is the object code, that's really specific to the microcontroller, is identical for whatever method you use. But there are different reasons for using MPLAB-X, different reasons for using GCASM, and different reasons for using PIC-AS. They all have different use cases. Generally, if you're not doing any debugging, just stick with GCASM. It's faster and you need less code to be installed. All the tools that I've spoken about are available. I will go to Chrome, open Chrome, I will go to the forum, files, support files, microchip compilers, and the latest compilers are all there, ready to rock and roll for your delight. So they are there. If you want MPLAB-X, that's the one to use. 5.87. I will upload 2.5 because it was only released today. So that's what I wanted to show you with respect to these alternative assemblers and MPLAB-X. Assembly is not a mystery because you can learn it via GCBASIC. Finally, the last one will give you a summary of what we've done across the whole pitch in the last video. Enjoy.